In this video, I'm going to be going through the answers to the preliminary or end of year exam for Year 11 Engineering Studies students. I'm not going to go through like full detail like I would if I was doing an exam review in class. I'm just doing this to get this out so that people can look at their answers and let me know if there's something they want checked. So I'm going through the student who got top results. So the lowest result was 10, the maximum was 43, the average was 27. I will talk about, so this is the question that was most answered incorrectly, which is what is the area under the curve? So Copeland talks about this is a very common definition of toughness, is the area under the stress strain curve. I'm not going to go into any more detail on that at the moment. I'll just say that that's definitely something you can find in Copeland's textbook. I've discussed it as well when we talked about stress strain graphs in materials, chapter 3 materials, video on chapter 3 materials. Okay, it's the one with Vickers from District 9 on the picture. Okay, calculate the stress strain at the proportional limit. This also was not answered well. So the answer is that you take the strain at the proportional limit and you divide by the original length. Sorry, you take the extension at the proportional limit and divide by the original limit. Now, in this case, I would take the answer as generally the idea is that in engineering you're really only supposed to go to the precision of between these gaps. But that's not, I mean, like that's something you learn about when you're reading like gauges and things. But in this case, I would say the answer can be quite reasonably taken as 1.25 or something like that. But as long as you got, I mean, because it's multiple choice, you should be able to get to the ranges. Even if you use 1.5 divided by, in this case, 400, it's going to be different for different people because you will have had different answers. But that's how you determine this answer. Okay, moving on. The stress in the steel, this is answered more often as this is answered correctly. So in this particular case, the students got this wrong, but this is the yield stress, 25 divided by 40. Let me just check. So that's how I'm typing it in into the calculator. 25,000 divided by 40 equals 625 megapascals. So that's that answer. For the UTS, what you need to do is you need to divide this number, 45,000, divided by 400, divided by 40 millimeters equals 1,125 megapascals. Okay, pretty sure this is the student who got the top marks. Just that she didn't do well here, maybe. We're going to run with it. That's what we're going to do. We're going to run with it. Okay. So to calculate the Young's modulus, what I do is I would say that you can just pick anywhere, just the gradient anywhere in this line. And so here's the nice easy spot to use. If you use 20, I can say, well, the force is 20,000 times length, which is 400 millimeters, divided by an extension of 1 times 40. So 400 divided by 40 is 10. So we're going to have 20 times 10 equals 200 gigapascals. Okay. I'm just going to check this off. Oh, yeah, okay. Check this off screen that this is actually someone who's done well. Yeah, it is. Just didn't do well early on. I suppose all things being considered, maybe this student just identified that this was not their strong area, and they decided to focus on the things that they could answer well because it was a timed assessment, and they're probably working up. From memory, I think this student was working pretty close to the buzzer. Anyway, okay, so calculate the force acting at F. There's a couple of ways of doing this. So you can split it into 45 degrees, and that's how most people would do it, is they take this, split it into 45 degrees. So if the load is 55 newtons divided by 45 degrees, so if I said that was 55 times sine 45, 55 times sine 45, instead of saying sine 45, what I'm going to do is just say 0.707, because I just know that is the same thing. And I'm just getting my calculator in the right mode. So 55 times 0.707 equals 38.88. And then I'll have a vertical component and a horizontal component, both of that same value. We can ignore the horizontal component because it runs through point A, right? It's not perpendicular at all. So if there's no perpendicularity, there's no force. So we have 38 times 1300, or actually we're going to do this in meters. That gives times 1.3. That gives me an answer of 50.55 kilonewton meters going anti-clockwise. So that means I'm going to need a clockwise force to counterbalance that. If I have 50 kilonewtons going that way, I need to have 50 kilonewton meters going the other way. So if it's 50 kilonewton meters, if I divide by 0.6, that gives me 84 is the answer. So I don't know why it didn't show the answer there in the feedback. Yeah, but anyway, 84.3 is the answer. Okay, calculate the reaction. Well, so if this is going to the left, that means that we're going to have, sorry, if this is going, yes, this is going to the left, that means our reaction is going to have to be going up to the right. So if it's going up to the right, because this is going down, this will be going up, so the reaction will have to be going up to the, yeah, up to the right. So, and then finally calculate the velocity ratio of the lever. So the easiest way to do this is to consider the perpendicular distance. So if we have a 45-degree triangle like this, then 1300 times sine 40, or in this case we can just say 1300 times 0.707, which is the same thing, is 919. And 600 divided by 919 gives me that answer. Now, some people do the inverse of that number, but that's not the case. Because this is a first order lever, it can have a mechanical advantage when velocity ratio equal to, greater than or less than 1. In this case, because the effort is traveling less distance than the load, the mechanical advantage is actually going to be less than 1. So it's 0.065 is the answer there. Okay. So this question, what we have to do is we have to compare the two diameters. So we've got 60 and 60 divided by 128. That's the diameter ratio of 0.35. Actually, we're going to go the other way around. We're going to go 168 divided by 60. And that gives me a diameter ratio of 2.8. That means the area ratio is going to be 2.8 squared, which is equal to 784. 784 times 100 newtons gives me 7.84 times 100 newtons gives me 784. Okay, now this question here, I'm not sure why, but for some students the calculation came out wrong. For some, for 1/3 of the students it was fine, but for 2/3 of the students the answer was incorrect. You can see here that I've actually awarded that mark. I've just manually overridden it, and I've clicked here as 1 mark. So, and you should see that it says if the number is incorrect, there should be a little quote on the bottom here. It's possible that didn't save for someone. I haven't gone and double checked everyone's, but that's why I'm making this video. Okay, so identify composite material. Those people who said just timber or wood, even worse, I sent them this link, which is technically correct, the best kind of correct. But engineered timber, that's a great answer. Plywood, that's a good answer. Concrete is a good answer. Carbon fiber is fine. Someone said Kevlar. Kevlar is not a composite material. Okay, engineered material, engineered timber is used in construction. Yep. Okay, so they've gone into some details. I think that answer is fine. Yeah, so in the case of, I don't want to go into every single possible answer, but engineered materials, it can give longer lengths, can be cut into different shapes. Some people just talked about concrete as being concrete is a composite material, even if they didn't say reinforced concrete. Reinforced concrete would be the better answer, but if they just said makes for a good foundation material, that's fine. Some people just said composite materials have good strength to weight ratios. You can't say that because you're not being specific. It says justify the engineering application of a composite material, right? So they're saying a specific composite material. Okay, so the questions here could be different for different people. If you had the axle should be made out of steel. Headlight that covers are made out of acrylic. There's nothing that's out of ceramic. That's a and wire. That's a what they call a distractor, and the wiring is made out of copper. Copper is for its conductivity. Ceramics have refractory. Steel has strength, and acrylic has transparency. What is the appropriate material for steel? The steel axle is machined. The copper wire is drawn. The acrylic is injected molded. Okay. What's the difference between work hardening and annealed steel? Work hardening has elongated grains, has increased strength and hardness, whereas annealed steels have large equiax grains, which are more easily machined and better toughness. Describe the process of quench, hardening, and tempering. Heat up to 100% austenite, then quench in oil or salt water. This results in martensite. Heat to between 200 and 600 degrees. This results in a very hard, very strong, and not too brittle product. This process makes the hardest objects, hardest engineering, very hard objects used in engineering applications. I'm not taking marks off because that last line is maybe a little overreaching. Okay, now a lot of people would just say like E, and they didn't name the thing. One of the marks is for naming the object that you're describing, right? That's part of the thing. So I was pretty reasonable. Like, I mean, if someone said cup, or someone said ball or head, I wasn't going to be too picky. You just had to make an attempt. So in this case, they've said the acetabulate cup is made out of titanium. Titanium's used because it's biocompatible. Yep. Doesn't corrode. Yep, that's good. Okay, the liner should be injected molded, and then they've gone through the process of how you injection mold them. That's a very good answer. No problem with that whatsoever. Now, just be noteful that you might have a cross in some of these. I don't know why that is. I don't really use Google Forms for non-multiple choice questions usually, and in this case, I don't normally use it for exams. So we're just making the best we can. So have a look, and it's the number that matters. So crutches and wheelchairs. Now the thing is, there's only one mark to identify two things. If you said one thing that was correct, I, in my head, gave you half a mark. You're not allowed to give half marks in the HSC. But what we can do is we can say, well, look, this is a half mark, another one's a half mark, and you can kind of pay the mark off somewhere else. So that's what I've done. I've tried to specify if you have in some cases where one of the two is correct, I have in some cases spelled out which one is which. A lot of people wrote down prosthetics. Look, in another world, I could see that you could write prosthetics and still get that as correct, except for the fact that I've described prosthetic in the question. So therefore, prosthetic is not acceptable. Okay, describe an example of a Okay, so now I'll tell you, I think this is probably the only student I've done this for. In this case here, they've said describe an example of a diagnostic biomedical technology, and they've written scanners and sensors. Look, if I was being meaner, I would say that this is half a mark, and then I can't give any marks. Because although they have not given a description, they've just identified two things. Now the thing is, my attitude is identifying two things is worth a mark, or describing one thing is worth a mark. And so although this student hasn't described the thing in question, it also, I can't remember, I marked this a little while ago, I've marked 35 tests or something like that. It's taken me 12 hours. That, maybe not a full 12 hours, but it's taken me quite a while. Like I had dinner. Anyway, but I got distracted. But I may have paid off half a mark somewhere else. So explain how technology influences things. So here we talk about modern prosthetics could allow for movement. Yep, that's modern technology. Engineers design devices that assist in yada, yada, yada. Okay, this is a really interesting question because it's only one mark. And so if you say, well, what do engineers do? I would say, I mean, for me, my answer would be that engineers design, implement, and maintain assist devices that are used to treat medical conditions and assist people with medical conditions. That'd be something like that would be my answer. Now, that said, it's only 1 mark, so I'm going to be pretty flexible with this. But you can't just say, oh, engineers find solutions. I mean, I at least want to see the word design somewhere, ideally. So, look, if you feel as though you've been treated unfairly, by all means, let me know. But anyway, moving on. That was one I felt as though wasn't particularly well answered. And it's only worth 1 mark, but, I have to be binary. I have to say whether or not something's over the line or not. So that's where I'm at. Okay, next. Compare the environmental impacts of recycling. Okay, generally all engineers are looking to reduce the amount of material waste that goes into manufacturing. Reusing is also beneficial. Recycling requires electricity, which is used as non-renewable resources, hence produces excess carbon dioxide. Those two things are not related, but what they probably mean to say is which also produces carbon dioxide, which is not good for the environment. Additionally, not all recycling makes it to the recycling plants with overall landfill. Now you got to remember, this is only worth 2 marks, so that's a really extensive answer, so I'm quite happy with that. Now, one of the things I have here is, aside from in this question, there's two things where there are bugs. Aside from that, I have this set of things where I have ready to copy and paste, where, like my stamps that I can use, right? So first of all, sometimes people just answer a question that wasn't asked. They give an answer, it's a good answer, it just doesn't answer the question I asked. Right, then I have people who haven't understood the glossary of key terms, right? That's really important that you understand the HSC keywords, right? I've posted these to the Facebook. Glossary keywords, there we go. Now, you should know these words, right? And know how you use them. Now, in most cases, I don't think it's a definitional thing. I think just people didn't even read the question. But what I've got here is, this is not a comparison. So where it says compare, you need to compare. Where it says describe, you need to describe. Electrical components, sometimes people don't write down electrical components. They might say computers, and they are not electrical components. Components we're talking about are things like transistors and diodes. We'll get to that. This is not an example where people say where I say provide an example, and the person hasn't actually, they've said, let's say, provide an example of composite material, and they said, composite materials are really good. And it's like, well, that wasn't an example. Okay, so let's have a look. Biomedical engineering has been extremely beneficial for society. It helps people regain independence, complete tasks. Okay, moving on. Biomedical engineers, that's 4 marks. Outline how benefit engineers must behave ethically. Okay, so I saw a lot of people say animal testing. There were some other good ones. I only saw one cochlear implant, which is an interesting development. I guess maybe because I really drummed home animal testing this time around. People talked about we have to consider who we test on and like the financing. That was a good answer. Because this is 2 marks, I have a bit more flexibility, but I try not to punish people who, so if someone said animal testing, they were getting 1.5 marks sort of by default there. So because I think that's just such a strong example. But this is a very well described example of it. Now, it needs to be an actual ethical consideration. You can't just say, oh, engineers must behave ethically, or engineers must ensure that they act in the best interest of the community. That's not an example. So you've got to remember that you actually have to give an example. Okay, describe an example where health and safety... Okay, so the one that I like the best is asbestos. If I see the word asbestos and I see the word cancer, they're going to get 2 marks. But here we've got, you need to make sure that the material is bio-inert. This is why titanium is used, because it's non-toxic. Yep, good choice. Brakes. Okay, so this is probably the most commonly used answer as well. An example where engineering compares against a pre-20th century alternative, where people compare block brakes to modern brakes. These are pretty commonly used answer. All houses must have safety switches, and they must have fuse boxes, which were even better than that, replaced with circuit breakers. Now, there are people who said, oh, you must all have fuse boxes and warning signs, or a couple of other ones where it's like it's not a residential consideration. You haven't described a residential thing. So what I'm really looking for is I don't really like fuse boxes, but I might have given a 1 mark for fuse boxes under the right circumstance. These days it really should be circuit breakers. If this didn't say circuit breakers, I'd probably still have given this 2 marks, because it's still a good description of 2 separate things, 2 separate examples. But what I really want to see is safety switches, and safety switches, also known as RCD devices, residual current devices, circuit breakers, and earthing, double insulation. Yeah, that'll do. So though, if you just list 2, right, that's not description, right? So you need to actually describe them to get 2 marks. So that's a good answer. Okay, describe 2 electrical components that use semiconductors. The word answer I'm looking for is transistors, act as switches, diodes allow the flow of electricity in one direction. Again, if you just write those 2 things, you only get 1 mark, you don't get 2. Okay, so in this case here, let's have a look in this scenario. We've got A is 0 and B is 1. So in that case, they're both the same. So I've got 0 and 0, and AND gate's going to be 0, right? So P is 0. 1 and 1, an OR gate is going to be 1. In this case, I've got 0 and 1. So the OR gate says, well, okay, is either of you 1? And this guy here says, yeah, I'm a 1. And so the OR gate's like, you're in. But then the not dot, just to be a jerk, flips it and reverses it. So it says 0, 1 becomes 0 now. So we're going to get 0, 1, 0 is the answers. 0, 1, 0. Your case, the specific answers for you might be different. Okay, so here we've got 12. It's always 12 volts, but it's the ohms that are different. Now, I'm not going to go through resistance. I've talked about this in other videos, but I'll just say that if you have 18 ohms and 18 ohms, well, you're going to have 1 over 18 and 1 over 18. 1 over 18 plus 1 over 18 is 2 over 18. If you invert that, you get 18 over 2. 18 over 2 is 9, which happens to be half of 18, right? 2 resistors, equal values, it's going to be halved. 9. So, golly Moses, no, it's actually not that way. So it's going to be, so we said that if that's the case for 9, let's have a look at what are our options. We need to get to 18. So we know that this is going to be half as much as that. So if we divide 18 by 1.5, we get 12 ohms. 12 milliohms is what we need. Okay, calculate the current in the circuit. Well, V equals IR, so it's 12 divided by what was the total resistance of the circuit? Was 18. 12 divided by 18, and then divided by 1,000, because it's milliohms, times 1,000, sorry, because it's milliohms, which gives us 667. Okay, calculate the power of the circuit. Now this one here is one that I got wrong. I'm not sure why. I think that maybe when I was typing up the spreadsheet to populate all these answers, I think I used times instead of divide or something like that. Okay, but so let's just use, you can work this out lots of different ways. So if you type in like power formula, let's have a look. So we get something like this. We use this blue one, right? So you could go V squared divided by R, right? So that would give us, that way we're only using the information provided. So we've got 12 squared, which is 144, divided by 18 equals 8. Now, it's not 18, it's 18 milliohms, so we have to divide, we divide by 1,000, which gives us, multiplying by 1,000, which gives us 8 kilowatts. Some people did actually get this right. They did answer it in separately. I do appreciate it. Sucks that the correct answer wasn't there. It really, it makes my heart sad. I'm glad that I gave an other so that people could type in the answer. And there were people who typed in the right answer. So we had discussed that prior. In terms of drawings, I will get up a couple of the better drawings that people did. Nearly at the end, and I'll just give a couple of examples of drawings. So generally, I think we did pretty well. When I compare this to my Year 12 class, I think that we did quite well. So I'm just not sure if that is going to be. If that name is going to be in the thing. Look, what I'm going to do, I'm just going to adjust this view window for a second in OBS. Okay. Hold on. Okay, sorry about that. After all that, I don't know if it really made much difference. But okay, so I gave this out 5 out of 5. Like, this is pretty well done. This would have taken some time. The only problem I'd say is the circles don't look quite isometric, but it's pretty good drawing. Maybe it's not quite tall enough, but pretty good. Okay, let's move on. Okay, so the top view is in the right spot. The drawing looks more or less okay, probably 2 marks. I don't think I gave less than 2 marks. It's not that I'm opposed to the idea of giving 1 mark. Look, I could actually get the marks up. Hold on. Okay. So, hold on. Okay. This one here, what do I give it? I give it 3, I think. Okay. I gave this 2. Now, you might say that's a bit harsh, and look, the shape is really good. They've shown center lines, they've shown hidden detail. The problem is they haven't shown a top view. I could see a world where I could, maybe if that person came to me and said, hey, look, I think this is worthy of a 3, I might, I might consider upgrading it. Okay, this, I gave that a 5 as well. Again, I would this one here, this circle here is a lot better than that circle here. I even like that they've shown the circle behind. That's pretty good drawing. I mean, it's wonky, and but it's only supposed to be freehand. Okay, so this is a pretty good effort. I think I gave this something like, for both of them, I gave this 8 out of 10, and this here, it's a little bit disproportionate. There's no center lines, but yeah, I think that was the highest for drawings. Okay, I gave this 3, and you might say that's harsh. The big thing it doesn't have is it doesn't have this line down this page here. Again, I could probably, I think maybe I took marks off for the position of these circles and the fact that it wasn't rounded. I'm not sure if they're supposed to be rounded actually. Now that I think about it, to that anyway. But I think I could be talked into bumping that one up. Let's have a look. Okay, I gave this 4 if you can believe it. Now it may even be viewed from the wrong side, but at least it has something that's close to a centerline. The centerline's not ideal. It looks more like a hidden detail line than a centerline, but they tried. There's a difference between line weights. They've shown hidden detail here. The top view more or less lines up with the front view. The side view is viewed from the right position, even if it's maybe from the wrong arrow, or like it may have been on the wrong side view. But yeah, I mean, this is pretty good. They've shown a lot of information there. At first blanch, I wasn't as impressed, but I like it better. This one here's not bad. I gave this 3. Yeah, no center lines. Center lines would have given it an extra mark. I gave this 2. It's probably a bit of a generous 2. I'll give you that. I think this is the closest I got to 1. I think I originally gave it 1, and then I looked at some of the other things I gave people 2 for, and I'm like, well, look, it probably is a 1. It probably is a 1, but I think I had already given something else that was worse than this. Okay, this one here. Oh, okay. This one's got 2 parts. I was going to say I gave that 5, and that seemed like a lot. But yeah, combined, I could maybe even give an extra mark for that, for the 2 of those. I gave that 5. It probably could have been 6 in total. I think 3 and 2 was probably right there. Okay. What did I give this? I think I gave this a fair bit of marks. So I gave this 6. I gave this 3 and 3. Yep. This is on the wrong side. There's no center lines. This is probably better than that. It's a bit wonky, but you know, like this, the fact that I can see this line. But all in all, I mean, it's a freehand sketch. You know, I'm trying to be generous here. This one here, I also gave 6. Same sort of thing. Okay, this one here I gave 2, and I think that's why I went and gave the other one. I went back and gave the other one 2. I'm like, well, if I'm giving this 2, and I'm like, why am I giving this 2? Well, they've identified the general shape, and it's like, okay, yeah, the general shape is terrible, but at least they've got the top view in the right spot. So that's 2 separate concepts, right? So you might say that's being too generous giving this 2 marks, but they didn't they got the 2 shapes more or less generally correct. I'm also, you know, after looking at 30 of these, I'm like, oh, okay, I do kind of see the shape has a certain resemblance, but they also then got the top view lined up on top. Now, the problem with this is that they see how here the shape, they've drawn this in isometric, which is wrong, and then it doesn't line up. Like if the top view is not on top, you know, and that's part of what you're supposed to do, is drawing the top view on top. If you draw them on different pages, I can't give you a mark for that. So even though this is not a bad attempt, I can only really give marks for one of them. So you know, I gave that 3. I could probably have gone to a 4 on that. If that person appeals, I'll probably give them a 4. Okay. Now, so here the big problem is that this looks okay, but no center lines, mind you. I don't really like where those dimensions are, but I'm not taking marks off because I didn't ask for dimensions. I'm not going to deduct marks. But this top view is just totally wrong. Like it's in the wrong direction. It's in the wrong spot and in the wrong direction, and that really does not help it. So yeah, there's definitely a loss of marks there. They got 3, and even that, I mean, like, okay, they've shown it's a better attempt than another student, you know, those 2 2s that we saw. But now this I gave 4, and I'm pretty happy with that. The only problem is that the top view is not on top, but it's a pretty good drawing. They've shown a lot of detail that other people haven't. I mean, it looks 3.5 that I've rounded up to 4. and this one here I think was the best drawing. So we've got top view on top. The side view is on the wrong spot. They probably didn't need to show that hidden detail, but aside from, and they didn't show center lines, but aside from that, that's a really pretty good drawing. So they've lost 2 marks. The side view is very good. Now I just want to have a quick look before I go on. I just wanted to say that, yeah, so this is curved. So I just want to remind people that when people say, oh, why did I lose marks? Remember, this is curved. So that is a consideration that I did think about when we were looking at these. So let me just have a quick look at. Yeah. Anyway, okay, so that's where we're at. I just looked back at that first one. The first one doesn't have actual curved corners, so that is a consideration that it probably needs to be, whoops. It doesn't have, but I do think compared to everyone else, just the fact that this is like I'm not taking marks off for people who didn't use a ruler, but this student's used a ruler, and I just think just the quality of that drawing is much higher than everyone else's. Okay, with that said, that's the feedback I'm giving for this assignment. If you are unhappy with the answers I've given, let me know, and I'll try and get back to you.